ಆಕಾಶವಾಣಿ ಮಂಗಳೂರು.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ
ಬಾನುಲಿ ಶಾಲೆ ಎಸ್ಎಸ್ಎಲ್ಸಿ ಪರೀಕ್ಷಾ ಸಿದ್ಧತೆ ಕಾರ್ಯಕ್ರಮ.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ.
ಇಂದಿನ ವಿಷಯ ಆಂಗ್ಲ ಮಾಧ್ಯಮ ಶಾಲೆಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಾಗಿ ವಿಜ್ಞಾನ ಪಾಠದ ಮೊದಲ ಭಾಗ. ಭಾಗವಹಿಸುವವರು ಸರ್ಕಾರಿ ಪ್ರೌಢಶಾಲೆ ನಾರಾವಿ ಬಂಟ್ವಾಳ ಇಲ್ಲಿನ ಶರೀಫ್.
ಕಲಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ, ತಿಳಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ.
I heartily welcome to all the students, teachers and parents for today's SSLC radio program on science subject. In the previous radio program, we have discussed about some of the chapters regarding to the science. And today we are here to discuss on the remaining chapters, especially on the 3 chapters, that is chemical reactions and equations, acid, bases and salts, and one more from the biology, that is how do organisms reproduce. So students, I request you to make a note on the most of the repeated concepts I say, and also there are some concepts which are explored very low. So when you come for this chapter, chemical reactions and equations, here the most repeated concepts we get is the type of chemical reactions and decomposition reaction and its types, displacement reaction, double displacement reaction, oxidation and reduction reactions, corrosion and methods to prevent corrosion, and also we have the rancidity and methods to prevent rancidity. So when we go through this chapter, here we can find that first we may get the questions like what are the observations you make to determine whether the chemical reaction has taken place or not. So for this we need to have the 4 points. We need to have 3 changes, that is change in the state, change in the color, change in the temperature, and the 4th one will be the evolution of gas. So this is a key points to keep in mind for the observations to determine the chemical reactions. And next when we go there, we have the chemical equations and how it is balanced here. So chemical equations, if you see here, we need to balance it and we need to say why chemical equations should be balanced. When we get the question why chemical equations should be balanced, we need to know the law of conservation of mass, which we have studied in the earlier classes. According to the law of conservation of mass, mass can neither be created nor be destroyed. So we need to balance the chemical equations. So when I go further, I can find that we need to learn the different types of chemical reactions. So when we go through the different types of chemical reactions, basically we divide them into 4 types. So if you see the 4 types, it's very easy. One is the combination reaction, and second one will be the decomposition reaction, and third one is the displacement reaction, and the 4th one is the double displacement reaction. So for these 4 reactions can be easily we can remind by the word like C3D. C is for combination, 3 Ds we have, that is one is for the decomposition and the second one is for the displacement and the one more is for double displacement. Here whenever you are going to see the types of reactions, here you need to learn 2 things. One is the definition and other is the example. Suppose if you have a combination reaction, here we define that as a single product is formed to form 2 or more reactants, and you need to cite the examples also for that. For example, magnesium reacts with oxygen to form magnesium oxide. You can write either the word equation or you can write the sign equation, so symbolic equation. And then you have the decomposition reaction, and it is a very very important in this chapter because many a times we have got the questions based on this decomposition reaction. Here if you see what is decomposition reaction, we can say that a single reactant breaks down to yield 2 or more products. Okay, and here in decomposition we need to concentrate on the 3 types of decomposition reaction. Now let us see which are those 3 types of decomposition reaction. One is the thermal decomposition, and another one we have is the electrolytic decomposition, and the last one we have is the photolytic reaction, or also we can say as a photochemical reaction. Here what is these types of decomposition reaction? Here we need to give the energy for the decomposition. Based on the energy you are giving to the reaction, we are categorizing it to 3 types. If you see the thermal decomposition reaction carried out by heat, Here you can find examples also, like when lead nitrate is going to, we get heated, it is going to form the lead oxide, nitrogen dioxide and oxygen. And also it is very important to keep this reaction in mind, because in our textbook we have one of the diagram base for this, and you can find the fumes which are coming in a brown color in this reaction. They may ask which is the brown color fume here. The brown color fume which is formed in the product is the nitrogen dioxide. So we need to concentrate on this reaction. And also we have the two more examples for this reaction. That is, when you heat the ferrous sulfate, it is going to form ferric oxide, sulfur dioxide and sulfur trioxide. In the same way, we have one more, that is the limestone, calcium carbonate. When it is going, when we heat it, it is going to form the calcium oxide and carbon dioxide. These are the three types of decomposition reaction, its definition and the examples. Okay, next we are going for the electrolytic decomposition. Here when you go for the electrolytic decomposition, we need to concentrate here. It is a decomposition reaction carried out by electricity. We are going to use the electricity as a source of energy here. So what is the example here? If you take the example here, when we are going to give the water electric current, it is going to decompose into two gases, that is, one is hydrogen gas and another one is oxygen gas. Students, I think you know this reaction because we have the diagram which is recommended by the board for the examination purpose, that is electrolysis of water. Here always you need to keep in mind this diagram is very important, and also you need to keep in mind that at cathode always hydrogen is going to liberate and at anode always oxygen is going to be liberated. So this is a very important thing, and I think always we'll be having a confusion based on these things. Okay, now I'll give you a mnemonic for this. For example, we can take the word like Odisha. If you take the word Odisha, the first letter of the Odisha is O and the last letter of the Odisha is A. The first letter is O, that is oxygen, and the last letter is A, that means anode. So we can remember easily that oxygen is liberated at the anode, and in the vice versa we can say that hydrogen is liberated at cathode. And also when you draw the diagram, you need to know the amount of hydrogen which is liberated and amount of oxygen which is liberated. And if you see the diagram properly, you can make out that hydrogen liberated will be more and oxygen which is produced there will be less in number. Okay, that is due to the formula. We have the H2O in the formula itself. We have why the hydrogen is more in number. Okay, next we have the one more decomposition reaction, that is we call it as photolytic reaction or photochemical reaction. What is this photo means? Usually we know that photo means light. So if the decomposition reaction is carried out by light, we call such reactions as photolytic reaction. Here I think in your textbook we have one of the diagram there. We have a sunlight which is open and we have a petri dish, a china dish where the silver chloride is being kept. Because when we keep the silver chloride open to the sunlight, it is going to decompose into silver plus chlorine. So this is the example for which one? Photolytic reaction. And also we have the one more example, that is a silver bromide also behaves in the same way, that is it is going to decompose into silver and bromine. So this is all about the decomposition reaction. Please concentrate on these things. And we have the one more important reaction, that is a displacement reaction. As the name itself it is indicating that displacing. What is it going to displace? So if you see the definition, we can see that a reaction in which more reactive element is displaced by less reactive element. Fine. Here we need to know about the reactivity series. I think we have studied this reactivity series in one of the lessons, that is the metals and non-metals. Based on that thing, we can know which is more reactive and which is less reactive. For example, in your textbook, you can find the figure that one test tube with a blue color, when you keep iron oils on it and after some time it is going to turn into green color. So means it is one reaction where we are going to give the example for displacement, that is Fe, iron, reacts with copper sulfate, SeSO4, to form ferrous sulfate and the copper. Here you may get the equation and you may give, they may ask the question based on the color also, because the copper sulfate color will be blue in color. After the reaction, the solution turns green, which is nothing but ferrous sulfate solution. So in the same way we have the other examples also, that is the zinc reacts with copper sulfate to form zinc sulfate and copper, and also lead reacts with copper chloride to form lead chloride and the copper. These are the reactions which we have for the displacement reaction, and whenever you practice these questions you need to make out the examples also. And then we have the one more important reaction, that is a double displacement reaction. What is this double? Displacement is happening, but it is happening two times. So we use the word double here. So when we define it, we just define it as a reaction in which exchange of ions between the reactants. That's it. Okay. Here we have the one of the equations for this and reaction for this. That is a sodium sulfates reacts with barium chloride to form barium sulfate and sodium chloride. This is one of the most important reaction for the double displacement. And also here we can find that the one of the product formed, barium sulfate, is insoluble in water. We call that as a precipitate. So we can call this reaction with one more name called as precipitation reaction. So you need to keep this in mind. This is also an example for precipitation reactions. Okay, fine students. I think now we are clear with all these four types of reactions. But whenever we see the papers, question papers, we can see that they are not only giving the balance the chemical equations. There may be a questions like they will give the some of the chemical equations. They will ask you to balance the chemical equations, as well as you need to label the type of reactions here. So we may get confused here. How to know the type of the reactions? So for this, we have a easy trick like, suppose in a reaction, only one product is there. Keep in mind, only one product. If we have only one product, we call such reactions as combination. Okay? One product means combination. Suppose if we have only one reactant, we call those reactions as decomposition reaction. Okay? One product, combination, one reactant, decomposition reaction. And if you have an element and the compound in the reactant side as well as in the product side, we can call them as a displacement reaction. I think you can keep in mind an element and a compound is there, and it is again going to form an element and a compound. We call that one as displacement. If in the reactant we have compound and compound, and in the same way in the product we have compound and compound, we can label that as double displacement reactions. And also identifying the type of reaction is very important here. Even the slow learners can go through these things. Now the next step we have is the one more type of reaction, that is we call it as exothermic and endothermic. Now the word itself is going to say exo. Exo means what? Liberating. Endo means absorbing. What it is going to absorb? It's going to absorb the energy. What it is going to liberate? It is going to liberate the energy. Fine. So we can define the exothermic reaction as a reaction in which energy is liberated. And in the same way, endothermic as the reaction in which energy is absorbed. Okay. We need to cite the examples for this exothermic and endothermic. For exothermic, usually we'll get many of the reactions from the combination reactions there. And when you take the endothermic reactions, we can see there we have studied all the examples for the decomposition reactions, right? For all the decomposition reactions, we are giving the energy for it, either in the form of heat or in the form of electricity or in the form of light. So we call these reactions also as exothermic reaction. See, when I go for the decomposition reaction, I'm going to study the examples for the endothermic reactions also. This is how we can practice our revision in this way. Okay, this is about the exothermic and endothermic reaction. Now, the very important thing in this chapter is the another type of reaction, that is oxidation and reduction. Here we may get the differences also. When we go for the differences, what is oxidation? Oxidation is the process in which oxygen is gained and hydrogen is released. If you take the reduction, oxygen is released or the lost and hydrogen is going to be gained here. So, but now when we read these concepts, it will be easy in a house. But whenever I'm going to write the examination, we get confusion. What is oxidation and what is reduction? For this, I can give you one mnemonic. Suppose I'm fat. If I'm fat, I need to reduce my weight. See, I'm telling the word reduce. Keep in the word reduce. Reduce means reduction here, okay? And what I need to do in my diet, I need to reduce the oil, okay? For reduction, I keep the word oil. For reduction, I have the mnemonic word oil. What is this oil stands for? O is for oxygen. I is for is. L is for lost. So we can keep the reduction as oxygen is lost. And the vice versa, we can say what is oxidation? Oxygen is gained. Fine. I think this will be easy for us to remember what is oxidation and what is reduction reaction here. Suppose in a chemical equation, both these oxidation and reduction are going to take place. We call such reaction as redox reaction. We call them as redox reaction. Here, redox reaction is the least repeated one, but also we have some of the chemical equations which we get from the redox equation here. For oxidation, we can see the one of the example in our textbook, that is Cu plus O2 gives rise to CuO. That is one type of oxidation reaction example you have in the textbook now. Now we have the three types of redox reaction here in your textbook. I will take the one example here. For example, CuO plus H2 gives rise to Cu plus H2O. Okay, fine. CuO plus H2, Cu plus H2O. What may be the question based on these things? Here, the many times they give the chemical equations and they say that identify the substance which is oxidized and identify the substance which is reduced. Many times we know what is oxidation and what is reduction, but we are not able to identify the substance which is oxidized and reduced. So whenever we get this type of question, no need to leave. Even it may be a below average student, it is very easy. Keep in mind, one thing we should keep in mind, that the answer is always from the reactant side, not from the product. I think you got it. Whenever you are going to say which substance is reduced or which substance is oxidized, the answer will be from the reactant side, not from the product. Now I take the example, CuO plus H2 gives rise to Cu plus H2O. Fine. Here, which is the substance which is having oxygen here? CuO, right? If it is having oxygen, it is going to lose. If it is going to lose the oxygen, what is the reaction which is happening here? We can say it as reduction. So which is the substance which is reduced here? CuO, and because it is having the oxygen. So keep in mind, the substance which is having the oxygen will be reduced and the one more one will be oxidized. In this way, you can make a trick to identify the oxidized substance and the reduced substance here. Fine. And here, the one more thing we need to concentrate here on the two important concepts, that is the corrosion and the rancidity. I think corrosion, what is corrosion we have there, and also importantly we need to find out that iron, we have the reddish brown color. If iron is in the on the surface of the iron, if we have the reddish brown color, we call them as a rust. That is nothing but a corrosion. And if you take the copper articles, if there is a green color, we say that it is corroded. And in the same way, if you take the silver, we can find the black color or the black dots. We call that as it is corroded. What is this copper green color is? Here, if you have the copper on the surface of the copper, if you have a green color, it is nothing but a copper carbonate. And if you take the silver, if you have the black color, we say that it is a silver sulfide. In the same way, if you see the aluminium utensils which you are going to get it from the market, it will be shining and it will be lustrous. Okay, after some time you can find the white patches in those aluminium particles. These white patches are nothing but it is corroded with the oxygen. So it is aluminium oxide, but it is not in the textbook. Fine, we can keep in mind. These are the things how we can identify. And corrosion, how to prevent the corrosion, I think you have discussed in the one of the chapter, that is the metals and non-metals here. And we have the one more concept, that is the rancidity. What is this rancidity? Rancidity is nothing but the oxidation of fat or oil and of the food particles, and we know that the smell and the taste of the food particles is also going to change. So this is what we call it as rancidity. It is also one of the very important thing we need to see here. And how to prevent this rancidity? So to prevent this rancidity, I think you need to understand this prevention of the preventive methods for rancidity. One is adding antioxidants to the food materials. Keep in mind, very important. And storing the food in airtight container, and flushing out air with nitrogen gas. And the refrigeration also can also help here. But the first three, whatever I told you, preventive methods, it is the best preventive methods to avoid the rancidity. Fine. So this is all about our chapter, chemical reactions and equations. Now let us move to the one more chapter for the chemistry, that is the acid, bases and salts. Okay, now whenever you go for the acid, bases and salts, here the most repeated concept will be the neutralization reaction. And example, pH scale and the importance of pH in everyday life. Most important is the salts. its molecular formula and its uses, and also chloralkali process and indicators and some naturally occurring acids. Fine. I think if you go for the indicators, it is not a major thing here. I think we all have studied about the indicators. Indicators we can classify into natural indicators and synthetic indicators here. Natural indicators, we see the turmeric. Whenever you apply a basic solution to the turmeric, we can find that it will be red in color. That is whenever you are going to wash the cloths with the turmeric one, you can see the red color. So it is a basic in nature. And if you take the synthetic indicators, here we need to discuss on the phenolphthalein and the methyl orange. Phenolphthalein, we know that in acidic medium it is colorless, and in the basic medium it is pink in color, and neutral also it is colorless. If you take the methyl orange, in acidic medium it will be red, in basic medium it will be yellow, and neutral medium it will be orange. This is how we can indicate. And here the most important thing we can see is the litmus paper. So we all know that in acidic medium, litmus paper turns the blue litmus to red, and in the basic medium it is going to turn the red litmus to blue. Okay, this is a major thing here, but they won't ask the question directly here. I will discuss it later how they will ask the question based on the litmus also. So here when we go for the chemical properties of acids and bases, here the first chemical property we say that metal reacts with the acid to form salt and hydrogen. I think we have the diagram for this for the board exam, for the board exam. That is the sulfuric acid reacts with the zinc granules and the testing of hydrogen gas. Okay, that's a very important diagram we need to stress here. And the second reaction we have here is the metal carbonate or the metal hydrogen carbonate reacts with acid to form salt, water and carbon dioxide. Okay, so in these two reactions, if you see, you need to understand which is the gas liberated here. Keep in mind, whenever you see the word carbonate or hydrogen carbonate, the gas liberated will be carbon dioxide. Okay, and rest of the things, usually we have the hydrogen gas liberated. So here if you go for the hydrogen in our syllabus, we can mainly stress on the two equations. That is, the metal reacts with the acid to form hydrogen gas. In the same way, if you go for the one more lesson, that is the metals and non-metals, there you have the action of water on metals. There also you can find the hydrogen gas is going to liberate. They may ask the question how you are going to test for hydrogen. I think it is a simple one. We have the diagram, we have learned the diagram. In the diagram itself we have hydrogen burns with a popping sound. But how you test for the carbon dioxide? Take a lime water. When you pass the lime water to the carbon dioxide, it is going to turn the milky. That's it. Okay. Now the most important reaction in this syllabus is a neutralization reaction. What is this neutralization reaction? When an acid reacts with base, it is going to form the salt and water. Keep in mind, I'm going to explain other two concepts based on this one now. Okay. Acid plus base gives rise to salt plus water. Okay. This is a neutralization, and also you need to study the example for this. They may ask the examples also. Fine. Next question here. Why metallic oxides are called as basic oxides? Fine. Why metallic oxides are called as basic oxides? I don't know. But do I know the neutralization reaction here? Yes, I know. What is it? Acid plus base gives rise to salt plus water. Okay, fine. What was my question? Metal oxides are basic. Instead of base in the above equation, write the metal oxide. What will be the equation then? Acid plus metal oxides gives rise to salt plus water. Same thing. The same product we have here. In the same way, why non-metallic oxides are called as acidic oxides? Keep in mind, neutralization reaction. You have the word here acidic. Instead of acid, what you can write here? You can write non-metallic oxides. So non-metallic oxides plus base gives rise to salt and water. Keep in mind, metal oxides react with base, salt and water. Non-metallic oxides reacts with base, salt and water. Okay, metal oxides reacts with acid, salt and water. Non-metallic oxide reacts with base, salt and water. This is a question they may give for the examination also. And here the one more important thing we need to form is the ions. So whenever you take the acids, the ion we say is the H plus ions, or we can say the hydronium ions, that is the H3O plus ions. And if you take the bases, you have the OH minus ions. And also they may ask the question, what are alkalis? So alkalis, if you go here, we have got the what are alkalis in the midterm examination also. The bases which are soluble in water, we call them as alkalis. And here we have the one more important thing is the dilution process. What is this dilution? Mixing an acid or a base with water, we result in the decrease in the concentration of ions per unit volume. This one we call it as dilution. In dilution, you should keep in mind, this dilution process is a highly exothermic reaction. So for this reason, we need to add the base or the acid to the water. We are not going to add water to the acid or base. Keep in mind, base or the acid is, we are going to add it to the water. How? Slowly with constant stirring. Why? If you add put a water or acid on water vigorously, what happens? The reaction is going to take place. It is highly exothermic and it may blast and it may cause the damage for you. So for that purpose, we need to understand this one. Okay. If you get a question in examination, keep in mind it is a highly exothermic reaction. And next important concept we have is the pH scale. What is this pH is here? So we all know that the pH scale from 0 to 14, it is going to range from 0 to 14. If it is 7, we call it as a neutral. If it is below 7, we call it as acidic. If it is above 7, we call it as a base. And here you need to keep in mind, strong acids gives more H plus ions and weak acids have less H plus ions. So lesser the value, higher will be the acidic in nature and higher will be the H plus ions. Okay, here how you may get the questions. For example, I will give you one question now. See here, I am going to use the first the litmus paper here. Identify the solution or identify the substances which turns red litmus to blue. Okay, now what may be my options here? I have 4 options here. One is the gastric juice, vinegar, soap solution and tamarind juice. My option will be soap solution because it is basic in nature. Okay, in this way they may give the questions also and they will give the pH of the other 3 things and they will say that what you need to do, you need to identify the pH and you need to say that it is A, B, C, D, pH they will give, and increasing order of hydrogen ion concentration, decreasing hydrogen ion concentration, all those things. And here important thing we need to see is the importance of the pH and also naturally occurring acids and its example. And very important is the chloralkali process, where here in chloralkali process, if you see that in cathode hydrogen is liberated, in anode chlorine is liberated, and near to the cathode we have the sodium hydroxide solution and its uses. Keep in mind, you need to discuss its uses. And then at the last, the very important we have is the salts. So whenever you go for the salts here, you need to make 5 columns here. Which are the 5 columns I need to make here? The one is the name of the salt, chemical name, chemical formula, and its preparation and its uses. Fine. Which are the common salts we have here? Bleaching powder, baking soda, washing soda, plaster of Paris. You need to have the chemical name as well as the chemical formula and its preparation and uses. Make the uses as simple as possible within 2 to 3 words, and this column is going to help you people. Okay, fine. This is all about our chapter acid, bases and salts. I think if you go for all these chemistry lessons, surely you may get a good marks. Out of 25 marks you can score very well and do well for your examination. I think students, we have completed the chemistry syllabus and we need to prepare for the other chapters. Now we will be leaving now and we will be continuing these classes in the next sessions. Thank you all. Thank you.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ
ಇದುವರೆಗೆ ಬಾನುಲಿ ಶಾಲೆ ಎಸ್ಎಸ್ಎಲ್ಸಿ ಪರೀಕ್ಷಾ ಸಿದ್ಧತೆ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಆಂಗ್ಲ ಮಾಧ್ಯಮ ಶಾಲೆಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಾಗಿ ವಿಜ್ಞಾನ ಪಾಠದ ಮೊದಲ ಭಾಗ ಕೇಳಿದಿರಿ. ಭಾಗವಹಿಸಿದವರು ಸರ್ಕಾರಿ ಪ್ರೌಢಶಾಲೆ ನಾರಾವಿ ಬಂಟ್ವಾಳ ಇಲ್ಲಿನ ಶರೀಫ್.
ಗೆಳೆಯರೇ ತಿಳಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ, ಕಲಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ.
ಆಕಾಶವಾಣಿ ಮಂಗಳೂರು.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ
ಬಾನುಲಿ ಶಾಲೆ ಎಸ್ಎಸ್ಎಲ್ಸಿ ಪರೀಕ್ಷಾ ಸಿದ್ಧತೆ ಕಾರ್ಯಕ್ರಮ.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ.
ಇಂದಿನ ವಿಷಯ ಆಂಗ್ಲ ಮಾಧ್ಯಮ ಶಾಲೆಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಾಗಿ ವಿಜ್ಞಾನ ಪಾಠದ 2ನೇ ಭಾಗ. ಭಾಗವಹಿಸುವವರು ಸರ್ಕಾರಿ ಪ್ರೌಢಶಾಲೆ ನಾರಾವಿ ಬಂಟ್ವಾಳ ಇಲ್ಲಿನ ಶರೀಫ್.
ಕಲಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ, ತಿಳಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ.
I heartily welcome all the students, teachers and parents for today's SSLC radio program on the subject science. In the previous radio program, we have discussed about the two chapters in the chemistry, that is the chemical reactions and equations, acids, bases, and salts. Today we are here to discuss on the three more chapters, that is from how do organisms reproduce and heredity and evolution, and one more is the magnetic effects of electric current. Here when I go for the chapter how do organisms reproduce, the most repeated concept we have in this lesson is the male reproductive system, its parts and function, placenta, its parts and function, asexual reproduction methods and the examples, what happens if egg is fertilized in human beings, what happens if egg is not fertilized in human beings, seed structure and menstruation. So if I go through this lesson, how do organisms reproduce? Here the first thing we need to understand the importance of DNA copying and in reproduction. Okay, so here what is the role of DNA here? Okay, and then we have the most important concept here is the modes of asexual method. So modes of asexual reproduction here, I think we need to have a table here. First we can have the serial number, and then we can have the modes of asexual reproduction, then we can have the definition, and then we can have the examples. In many a time of question paper, you see, go for the previous year question paper, many a time we get the diagram based question on this asexual type of reproduction. They will give you the diagram and they will say you to identify the organism and also the type of asexual reproduction which is taking place in this organism. So I think you need to concentrate on all the diagrams which is there in the asexual reproduction and also its name. So here how we need to do the chart here. So first, if I in the serial number 1, if I write, here we have the first mode of asexual reproduction is fission. In fission, we have two types again. There itself we can write binary fission and multiple fission. Then we should write the definition. What is binary fission and what is multiple fission and example. So here students, I'm telling you, we need to cite the example. We need to know the examples for this asexual method of reproduction. And then we have the fragmentation and definition and its example. In the same way, regeneration, definition, example, budding, definition and example, spore formation and definition and example, and the vegetative propagation, definition, example. Here when you go for the example, here vegetative propagation may be by root, by stem and by leaves. Here you need to cite the examples which are the organisms vegetatively reproduce by roots, by stem and by the leaves. And next we have the artificial method also we have here, that is a grafting, cutting, layering, tissue culturing, all those things we can see here. But concentrate more on the above 6 modes of asexual reproduction, definition. And also many a time what we do, we will get a confusion about this fragmentation and the regeneration. Keep in mind, fragmentation is not a necessary one. It is going to break up into many pieces upon maturity, and each piece develop into a new organism. When you go for regeneration, it is unknowingly. It is going to cut. The organism is going to cut or broken into many pieces, and each piece grows into a complete organism. And here you need to know the difference between the fragmentation and regeneration. Fine. So fragmentation is wantedly we are doing it. Regeneration is unexpected one. It is going to take place in a planaria and hydra. And next we have here is the sexual type of reproduction. Before going to sexual reproduction type of reproduction, here we need to keep two things. One, whenever we go for the sexual type of reproduction, here we will be having the two types of gametes. That is a male gamete and the female gamete. Here we need to know the difference between this male gamete and female gamete. Male gamete will be usually small and motile, whereas the female gamete will be large and it contains a stored food. This is a major difference here. Okay. Then when you go for here, we need to study the sexual reproduction in flowering plants as well as the sexual reproduction in human beings. If you go for the sexual reproduction in flowering plants, before going to the flowering plants, we need to find the parts of the flower and its function there. Calyx, corolla, androecium, gynoecium, that is the stamen and the pistil, all those things. Okay, fine. I think we can go for that one. It's not a problem. And here the very important thing we have is the one diagram we have it, that is the germination of pollens on the stigma. See students, here when you are going to draw the diagram, along with the diagram we can study the sexual reproduction in flowering plants also. How? Suppose when you start the diagram, here you are going to write the female reproductive part first. That is the stigma, style and the ovary here. Okay, here we are going to write these three parts: stigma, style and ovary. After that, what we need to do? So, after that, what happens here? The pollen grains are going to come and sit on the stigma. Fine. What is this process called? The transfer of pollen grains onto the surface of the stigma is called as pollination. See, along with the diagram, I'm going to study what is pollination also. Okay. Now you have the pollen grains there. Fine. What does this pollen grains contain? This pollen grains contains the male germ cells. Okay. Inside the ovary, we have the female germ cells. Okay. Sexual reproduction will take place only when these male and female gametes are going to meet. Okay. But we can see in the diagram that pollen grains are on the surface of the stigma, but we can find the female gametes inside the ovary. Now, how to contact this one? What happens after this? The pollen grains are going to germinate or form a tube-like structure. This tube-like structure you need to draw now. Okay, this tube-like structure, what we draw here from the pollen grain, we call that as pollen tube. Why do we need this pollen tube? Pollen tube is a path for the male germ cell to transfer to the ovary. They move to the ovary through pollen tube. Got it? I think you got it now. Okay. After the formation of the pollen tube, what happens? The male gamete is go towards the ovary and it is going to meet the female gamete. Okay. Now we have the fusion of male and female gametes. What is this fusion of male and female gamete process is called? We call this process as fertilization. After fertilization, the two cells, what we have, the male germ cells and the female germ cells, are going to form a single cell. We call it as a zygote. Okay, we have the zygote here. This zygote undergoes continuous cell division and it increases in size and it forms the structure. We call that as embryo. Got it? Now, where is this embryo? This embryo is nothing but, I think, when we open the cotyledons of the seeds, you can find a small structure, tip of the cotyledons. These small structures, what we see here, we call them as embryo itself. This is nothing but this embryo is going to form the seed. When you have the seed, then just when the favorable conditions gets to the seed, it is going to germinate. Okay, this is all about the sexual reproduction in plants. So you can keep in 9 points in mind. One is the first main things here, either it may be an animal or the plants. First thing in the sexual reproduction is production of male and female gametes. Then if in case of flowering plants, we have the pollination. Then we have the pollen tube is formed, and then the movement of male germ cell towards the ovary, and then we have the fusion of male and female gametes, that is the fertilization, and then it forms the zygote, and zygote is going to divide and form the embryo. From the embryo it is going to form the seed, and then it going to germinate. Okay, the fruit is nothing but inside a fruit we can find the seed. That fruit is nothing but a ovary we have here. This is all about the sexual reproduction in plants. Now, when you go for the sexual reproduction in human beings, so here we need to identify the changes in the girls and boys at the age of adolescence. You need to know these changes. And very important thing in sexual reproduction in human beings is a male reproductive system and its part and function. So, okay, now we have for example, testis. What is its function? Vas deferens, its function. Penis, its function. Fine. In this way, you need to make a chart here. Part, function. In the same way, for the human female reproductive structure, you need to make a columns here. One is the part and another one is the function. 4 parts we have here: ovary, fallopian tube, uterus and the vagina. In this way, if you make the chart, it will be easy for us to revise and also keep the things in our mind. And the very important in this lesson we have is the structure and the function of the placenta. What is the role of placenta? All those things we need to find here. How does embryo get nourished inside the mother's body, or explain the role of placenta? This may be the questions we get, and please go through this placenta and its function, which is very important for in the point of the examination. And then we have the one more important concept here. What happens if egg is fertilized in the human body, and what happens if egg is not fertilized in the human body now. Okay, so if it is not fertilized, we can say menstruation. If egg is fertilized, we can say it is going to form the embryo and it is going to form the, we have the baby there. Okay, fine. This is all about the reproduction. And also here the last thing we need to concentrate here is the sexually transmitted disease, or about the, we need to see about the sex health. So here we have the two types of infections which is caused due to the bacteria, that is a gonorrhea and the syphilis, that is a bacterial infection. And if you have the virus, it is going to cause the HIV or the AIDS. So this is all about the most important concepts, how do organisms reproduce. So this is about these things. Now if you go for the next lesson, which is, I think we can say that it's just as a continuation of the previous lesson itself, that is, we have the one more lesson is the heredity here. Go to the heredity. I think this is a very important chapter and a very easy chapter also we need to discuss here. Okay, if you go for the heredity here, the most repeated concepts we can see is the monohybrid cross, dihybrid cross, and sex determination in human beings. Now also at the present we have only these three concepts we need to concentrate in heredity lesson here. Fine. So here first of all we need to know first thing Mendel's experiment here. When you go for the Mendel experiment, first thing we need to know why Mendel has chosen a garden pea plant in his experiment. I think the answer is very easy here, because garden pea plant is having a contrast visible characters. I think either it may be tall, short, seed color and seed shape, flower color, all these things we have in the pea plant. So that was the reason why Mendel has chosen. And please make a note of these visible changes which we can see in the garden pea plant. Okay, and here in the next thing, when you see here, we have the two types of crosses here. One is monohybrid cross and dihybrid cross. Here you need to know the definition of the monohybrid cross. What is monohybrid cross? The cross between the two plants with one pair of contrasting characters. If you take the two pair of contrasting character, we call them as a dihybrid cross. This is very simple. Okay, they match this one also, definition also. And the most important part in the monohybrid cross is the checkerboard. So whenever you practice for the checkerboard, please students, make practice for the first filial generation, that is the F1 generation, as well as for the second filial generation, that is the F2 generation. Fine. I think this will be easy for you to practice and know the concept what it is. What we do, we usually practice only F2 generation, lack the concept. We are not going to understand the concept what it is. So whenever you practice, make sure that you are going to practice both the F1 as well as the F2 generation here. The most important thing we need to find is the ratio. So in the F1 it is not a problem. Usually we get the ratio in the F2 generation. That is, we have two types of ratio here. One is the phenotypic ratio and another one is a genotypic ratio. Phenotypic ratio usually it will be 3:1 for monohybrid cross, and it is 1:2:1 for the dihybrid cross. And whenever you go for the checkerboard, make sure that you are not going to take only one example. For example, we have only tall, short, or the tall and dwarf. Don't go for only that one. Take a round seeds and the wrinkle seeds, and the yellow flowers and the white flowers. Okay, in this way, if you take more number of examples, it will be helping you to know the concept, and you can solve any type of the checkerboard they are given in the examination here. And here next we have the dihybrid cross. If you go for the dihybrid cross, again we need to know the definition. It's checkerboard. When you write the checkerboard, once again I'm saying you, please practice for the first filial generation as well as for the second filial generation. And for the first filial generation, for us it is not very difficult to write the gametes, but we face a problem for writing the gametes in the second filial generation. Please make sure that practice for n number of times with different examples, so that you know the concepts and you know how to write the gametes. Because if you write the gametes, it's better you can do the checkerboard also. Fine. And here also we have the most important thing is the ratio. So if you take the dihybrid cross, you have the ratio 9:3:3:1. So whenever you write the ratio for either for the monohybrid cross or the dihybrid cross, make sure that, for example, if it is a tall plant for monohybrid cross, tall 3, dwarf 1. In this way you need to write. And in the same way for the dihybrid cross, you have the 9:3:3:1. Write all those things. For example, round and wrinkle seeds. In this way, okay, how many number it is. Round and yellow seeds, how many number it is. In this way, if you write, it will be easy for you people to understand. And here we may also get the question like, how you explain that traits may be dominant or recessive. Okay, traits may be dominant and recessive. If they ask the traits may be dominant and recessive, you need to explain for the monohybrid cross. If they ask the question that traits are inherited independently, if you get this sentence, you need to explain for dihybrid cross. Fine. I think this is about the monohybrid and dihybrid cross. The most important part in this chapter, whenever we have, is the sex determination. If you take the sex determination in human body here, we need to have a flow chart there where we take the male and the female, that is XY and XS, and you need to find out the ratio. That is, we get the 1:1 ratio. And if you write the flow chart and you need to explain, in female we have X and X chromosomes, in male we have X and Y chromosomes, and who is the one who is going to decide the gender of the child? We say it as a male. So this is all things, and it is a very important thing in this chapter. Now let us go to the last chapter on this session, that is the magnetic effects of electric current. When you go for the magnetic effects of electric current, the most repeated concepts here we have is the characteristics of magnetic fields and solenoids and electromagnet, and also we have the direction of a force on a current carrying conductor, that is a Fleming's left hand rule. And we have the safety devices used in homes and also short circuit. These are the most repeated concepts. But keep in mind, in the previous year we had the somewhere like motors and dynamo. But I think this year we may get a more question based on this magnetic effects of electric currents also. Here, first of all, we need to make 4 columns. Now see here, it is very easy to study this lesson. Nothing is there here. What we can do is that make 4 columns. In the first column, write the heading bar magnet. In the second column, write it as overall heading will be magnetic field, right? Under the heading magnetic field, we are going to make the 4 columns. First column will be the bar magnet, and the second column will be a straight conductor carrying electric current, and the third one will be a circular loop carrying electric current, and last one will be the solenoid. Okay, now we have all these 4 things, and below that, I think if you make a rough diagram of these things, it is easy for us to make out the magnetic field of lines. Okay, now first we have the bar magnet. Make a diagram of it. And seeing the diagram, we can see that this nature of the magnetic field around the bar magnet, we can say that it has both direction and magnitude, and it emerges from the north pole and merges at the south pole, and we have a closed curve. Field is stronger at the poles. No 2 fields lines cross each other. See, we can make by seeing the diagram itself. This is about the magnetic field of the bar magnets. And if you take a straight conductor carrying electric current, we have the diagram also for this one for the examination purpose. You need to concentrate on this diagram also. Based on the straight conductor carrying electric current, you can see the magnetic field there. However, the magnetic field, only one point is enough for us. The magnetic field are concentric circles. Based on this, we have one rule, we call it as right hand thumb rule. What is this right hand thumb rule? Now imagine you have a pen, right? All of you. I think you can hold your pen in a right hand now. Okay. The thumb is facing upward. Okay. I think you are doing this one. Okay. It's the pen is going to indicate that it is a straight conductor carrying electric current, and thumb indicates the direction of the electric current, and the remaining fingers what you have, which is wrapping around the pen, we call that as magnetic fields. Okay. Now the thumb is upwards. The thumb is facing upwards. If the thumb is facing upwards, remaining fingers, I think you can make out how is it. Either it is anti-clockwise or clockwise. I think you can make out now. See, the direction will be anti-clockwise. If the thumb is facing upwards, that is current is upwards, and remaining fingers indicates the direction of the magnetic field, it is anti-clockwise. Now what you can do, you can keep your thumb downwards, pointing downwards to the ground now. I think now here the current is facing the downwards, and how are the remaining fingers? The remaining fingers are clockwise here. Okay, this one you need to see. Current is flowing upwards, magnetic field will be anti-clockwise. Current is flowing downwards the wire, then the magnetic field will be clockwise. Okay, this is very clear, I think. And this question we have got in the model question paper also. You have a diagram based on that. See, there is a diagram. You need to answer the diagram there. So these diagram based questions are, you may get many questions from this lesson also. That is the magnetic effects of electric current. Please go through all the diagrams in this lessons also. And next what we have is a circular loop. Okay, magnetic field around a current carrying through a circular loop. So see the diagram here. At every point, the magnetic field will be concentric circles, right? Okay. And one more thing, in the last diagram, we need to see here there. As you move away the compass from the current carrying conductor, the deflection will be less. If the deflection is less, it indicates that the magnetic field is decreasing as you move away from the conductor. Okay. And if you want to increase the magnetic field, what you need to do here? Increase the current. Okay. In the same way for circular loop also, if you want to increase the magnetic field, you have two options here. One is increase the amount of the current you are going to pass, or on the other hand, you can increase the number of turns in the coil. Got it? You can increase the number of turns in the coils. And here in circular loop, the magnetic field will be concentric circles at every point, but straight line at the center of the loop. Keep in mind, we have one more word here, straight line at the center of the loop. This is how we make the differences. And at last we have is the one more is the solenoid. Here we need to know what is solenoid and how it is going to work. Here we can write what is solenoid, and it is not a big thing for us to write what is a solenoid, but here we have to know the magnetic field around the solenoid. How will you know the magnetic field around the solenoid? So here we can say that magnetic field around the solenoid is same as the bar magnet. But one thing you need to keep, there is a difference between the bar magnet and the solenoid. That is, inside the solenoid, the magnetic field of lines are parallel straight lines. That means it is same at all the points. It is same at all the points. This is a very important point we need to make out for magnetic effect of electric current. Okay, and other nature will be same as the bar magnet, whatever we have discussed. Then what is this electromagnets? Electromagnet is nothing but inside the solenoid, if you keep a metal or a iron, soft iron, what happens? It is going to get magnetic property. This one we call it as a electromagnets here. So here we can say what is electromagnet. If you have the question, we can discuss in this way. Okay, a strong magnetic field produced by inside a solenoid can be used to magnetize a piece of magnetic material like soft iron when placed inside the coil. The magnet so formed, we call it as electromagnet. What is the use of electromagnet? Using the electromagnet, either you can increase the magnetic field or you can decrease the magnetic field, but we can't do it for the permanent magnet. In this chapter, we have one more important, that is the force on a current carrying conductor in a magnetic field. This is very important from the examination point of view. Please go through the diagram where you have the horseshoe magnet and you have a piece of a rod which is carrying here. Please go through that, explain that experiment. And also you have one more important law here, that is the Fleming's left hand rule. What is this Fleming's left hand rule says? Here, stretch the, I think you can do along with me now. Stretch the thumb finger, forefinger and middle finger of the left hand. See that they are perpendicular to each other. What does the thumb indicate? Thumb indicates the direction of motion, sir. What does the forefinger indicates? It indicates the direction of the magnetic field. What does the middle finger indicate? Middle finger is going to indicate the motion direction of the current. Okay. What is the thumb? Thumb is the mother, and forefinger as father, and the middle finger as child. Okay. For thumb it is mother. Mother starts with letter M. I call it as motion. Okay. And for the forefinger it starts with F. I call it as magnetic field. That is a field, magnetic field. And for the middle finger we have the child, which starts with the letter C. I say it as current. So this is a way we can use this one Fleming's left hand rule also here. Fine, I think it's not difficult for us to understand. And here the most important part where we need to stress here is on the electric fuse. Here, whenever you get a word fuse, keep these things in mind. How is the fuse connected? Connected in series. What is this fuse? Fuse is a safety device. What is fuse made up of? It is made up of a metal or an alloy. Okay. And how is the resistance of the fuse? Resistance of the fuse is very high. What is the melting point of the fuse? Very low. Okay. If you keep these things in mind, it's enough. Whatever you get for the fuse, write these points. Okay. I think it is very easy to understand the concept fuse. And then you have the one more important concept, that is a overloading and the short circuit. Okay. Overloading can occur when live wire and the neutral wire come in direct contact. So here, why overloading is going to happen? So this may happen when the insulation of the wire is damaged or there is a fault in the appliances. In this situation, if you take here, if the current in the circuit is going to increase suddenly, we call this itself as a short circuiting. Fine. This overloading and the short circuit sounds similar. That is nothing but live wire is going to come in contact with the neutral wire. So here, what are the reasons for this overloading or the short circuit? So first of all, I told you insulation of the wire is damaged, or there is a fault in the appliances, or it is due to the overloading, which may occur due to an accident hike in the supply in the voltage. I think this will be we usually see in our homes there. And also the one more reason is that by connecting too many appliances into a single socket. These are the main reasons for the overloading. How to avoid overloading? So just write the opposite to this. How? The first thing is that you should use the fuse here. This is the one which can save us from the overloading there. And then make sure that wire is not damaged, and make sure that appliances is not damaged, and make sure that many appliances is not connected to a single socket. In this way, what we can do, we can prevent the overloading or the short circuit. And one more important thing we need to see here is about the wires. If you see about the wires here, we have the three types of wire. That is the live wire, neutral wire, and the earth wire. Live wire is the one which has the which is having the electric current passing through it, and one is the neutral wire, which will be black in color, live wire which is red in color, and earth wire which is green in color. So when you see about this earth wire, see here we can say that for many of the appliances which is made up of a metallic body is connected to the earth wire, which provides a low resistant conducting path for the current. So if there is any leakage of current to the metallic body, it is going to keep the appliances, keep its potential to that of the earth, so that we may not get the shock. This is all about the earthing wire, and we need to keep the thing in that earthing wire is having a low resistance. So this is about the magnetic effects of electric current. I think we have discussed all the chapters here. And now whenever you are going to write the examination, see here in science we know we have the three parts, that is the physics, chemistry, and the biology. Okay, whenever you have the three parts, most of the what we do, we have the MCQ questions not in a statement, that is 1, 2, 3, 4, 5, 6, 7, 8. We don't have that one. But what we do, if I don't know the MCQ question of the chemistry, suppose if you take the number as 14, what I do, I will write it, I don't know the answer, I will write it later. I will write all the things in a hurry. What I do, I just leave that question and I come. So first and foremost thing is that please write all the MCQ question number in the starting page and try to attend those things. If you don't know, please write the question number in the first page itself and leave it blank. Later when you go through the last, when you go for checking, you will get that question and you can write the MCQs here. And the important thing you need to do is that whenever you go for the choice questions, please see that which question write that question in a proper manner. That will be helping you a lot for preparing for this examination. And go through all the model question papers and the previous question papers. You may not get the same questions, but you will be knowing how will be the questions and how you are going to prepare for the examinations. All these things will be helping for you people. And also the thing is that we need to write all the question answers, so that it is going to help us in one way or the other way. And importantly in science, please go through all the laws. And whenever there is some of the laws like Ohm's law you have, and you have the Joule's law, and you have the Snell's law, whenever you are going to write the law, along with the law, just go to write the equations also. Because if there is any mistake in the law, you may get the mark for the equations also. Practice all those equations along with the law, and it will be helping for you people to know the equation as well as the law, and make the things as simple as possible, and it will be helping for you for the preparing your examination.
ಬಾನುಲಿ ಶಾಲೆ ಬಾನತರಂಗದ ಶಾಲೆ.
ಇದುವರೆಗೆ ಬಾನುಲಿ ಶಾಲೆ ಎಸ್ಎಸ್ಎಲ್ಸಿ ಪರೀಕ್ಷಾ ಸಿದ್ಧತೆ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಆಂಗ್ಲ ಮಾಧ್ಯಮ ಶಾಲೆಯ ವಿದ್ಯಾರ್ಥಿಗಳಿಗಾಗಿ ವಿಜ್ಞಾನ ಪಾಠದ 2ನೆಯ ಭಾಗ ಕೇಳಿದಿರಿ. ಭಾಗವಹಿಸಿದವರು ಸರ್ಕಾರಿ ಪ್ರೌಢಶಾಲೆ ನಾರಾವಿ ಬಂಟ್ವಾಳ ಇಲ್ಲಿನ ಶರೀಫ್.
ಗೆಳೆಯರೇ ತಿಳಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ, ಕಲಿಯೋಣ ಬನ್ನಿ ಗೆಳೆಯರೇ, ತಿಳಿಯೋ